How long does it take for an asphalt road to fail? That is a question that many people have asked. And there are many factors that affect the lifespan of an asphalt pavement. But there is one key factor that more than any other single variable will determine the longevity of your asphalt investment. You want to know what that is? Well, in this video, we're going to tell you all about it, so stay tuned. Welcome back to our channel, where we bring you new videos every week, focused on the value of good workmanship in construction and what it takes to build a quality project. If you enjoy great stories and learning something new, then be sure to hit the subscribe button so you never miss a new video. So how long should an asphalt road last? Well, according to the National Asphalt Pavement Alliance, or NAPA, an asphalt road can last anywhere from 20 to 40 years or more. However, most state departments of transportation design their pavements to last at least 20 years, with an average expected life of 30 years. Also, the Federal Highway Administration, or has developed design procedures that ensure a 50% probability that a new roadway will not require major reconstruction for at least 25 years. Now, while these guidelines may be sufficient for a busy interstate highway that sees millions of tons of heavy truck traffic every year, local municipalities often find themselves with roads that don't make it past 10 or 15 years. So what gives? Are local roads just built poorly, or are there other factors at play here? Well, believe it or not, there are several key elements to consider when trying to predict the service life of an asphalt road, such as the type of asphalt mix used in the pavement, the thickness of the asphalt layer, the subgrade, soil conditions, the amount and type of traffic the road will experience, the local climate, and possibly even the workmanship involved in the construction. However, above all other variables, there is one critical factor that will make the biggest difference in the performance and longevity of your asphalt road, and that is the structural capacity of the pavement. This simply means that the road has been designed and constructed to support the loads it will experience over its lifetime. There are two main types of asphalt road failures: rutting and cracking. Rutting occurs when the asphalt starts to deform under repeated loading, which causes permanent rut marks to form in the wheel path. Now, if you've ever driven down a residential street that hasn't been maintained, chances are you've seen some ruts forming in the road. It doesn't take much to get some light rutting started, and eventually the rutting becomes so severe that the road must be replaced. On the other hand, cracking is usually caused by tensile stresses that develop in the pavement due to repeated loading, temperature changes, or even the creep of the subgrade soils. When these cracks become too extensive, water can penetrate into the pavement structure, which accelerates the deterioration of the asphalt and the underlying layers. Now, although both types of failures can be caused by overloading, it's important to understand that rutting is mostly an issue of insufficient structural capacity, while cracking is primarily caused by an overly rigid pavement structure. In other words, if your road is too weak, it will rut. But if your road is too stiff, it will crack. In order to prevent these types of failures, the structural capacity of the pavement must be adequate to handle the loads it will experience over its lifetime. And this is where things start to get complicated. You see, when designing a pavement, engineers must strike a careful balance between the stiffness and flexibility of the pavement structure. If the pavement is too rigid, it will crack due to the lack of flexibility. On the other hand, if the pavement is too flexible, it will rut due to excessive deformation. To help them strike this balance, engineers use a number known as the Modified California Bearing Ratio, or the CBR. Now, in simple terms, the CBR represents the relative strength of a soil to support heavy loads. For example, a soil with a CBR of 100 would be equal to the strength of crushed stone, while a soil with a CBR of 50 would be equal to the strength of well-graded gravel. A typical range you would expect to see for a good subgrade soil would be somewhere between 6 and 12%. The problem arises when the strength of the subgrade soils is less than 6%. Because at that point, the engineer must add additional material to increase the structural capacity of the pavement. And this is where things get expensive. Adding more material to a pavement structure increases the thickness of the overall structure, which increases the cost. Therefore, adding more material to a pavement structure should only be done when absolutely necessary. And this is where the concept of design charts come into play. Using charts developed by the Asphalt Institute, or the AASHTO, engineers can determine the minimum thickness of asphalt required to support a specific level of traffic over a given period of time. These charts take into account many different variables, such as the type of loading, the number of load repetitions, the traffic distribution, the subgrade soil strength, and the expected life of the pavement. For example, let us say that an engineer is designing a 2-lane residential street with a 10-foot wide driving lane and a 5-foot wide shoulder on each side. The engineer determines that the subgrade soils have a CBR of 4%. Using the ASHTO chart, finds that the minimum thickness of asphalt would be 8 inches to support an average daily traffic count of 500 cars over a 20-year period. Now, depending on the severity of the loading, the engineer may choose to design a thicker pavement. For instance, if trucks are expected to use the roadway, the engineer may opt for a 10-inch thick pavement instead. But regardless of the thickness chosen, it's important to understand that once the pavement has been constructed, it's very difficult to increase the structural capacity. Adding more asphalt to an existing road is not a practical solution, since the added weight of the extra asphalt will only serve to weaken the pavement further. Therefore, it's critical that the engineer designs a pavement that is thick enough to last the expected lifetime of the road. Otherwise, the pavement will begin to deteriorate prematurely, and the road will need to be reconstructed sooner than anticipated. Now, I'm not saying that it's impossible to increase the structural capacity of a pavement after it's been constructed. It can be done. But the best way to do so is to use the ground beneath the road to help support it. In other words, if the subgrade soils are too weak to support the pavement, the solution is to strengthen the subgrade soils, not the pavement. This can be done through a variety of methods, such as removing and replacing the weak subgrade soils with stronger materials, adding a layer of geosynthetic reinforcement to the subgrade, or even consolidating the subgrade soils through dynamic compaction. All of these methods have been proven to be effective in strengthening the subgrade soils and increasing the structural capacity of the pavement. However, they are most effective when used during the initial construction of the road. Once the pavement has been constructed, it's much more difficult to strengthen the subgrade soils. Therefore, it's critical that the engineer designs a pavement that is structurally adequate to handle the loads it will experience over its lifetime. If the pavement is too weak, it will rut. But if the pavement is too rigid, it will crack. And in either case, the road will need to be reconstructed sooner than anticipated, which is costly. So the moral of the story is this: the secret to a long-lasting asphalt road is all about balance. Balancing the stiffness and flexibility of the pavement structure to handle the loads it will experience over its lifetime. If the pavement is too weak, it will rut. And if the pavement is too rigid, it will crack. But if the pavement is properly balanced, it will last for decades. Thanks for watching. If you enjoyed this video, be sure to give us a like and tell us what you thought in the comments section below. We appreciate all feedback, good or bad, and we try to respond to everything we can. Also, we have another video that we think you might like called What Causes Asphalt to Fail. You will learn all about the different types of asphalt failures and what can be done to prevent them. You can watch that video here. Finally, if you haven't already done so, please go ahead and hit the subscribe button so you never miss a new video from us.